Now we're going to start solving equations that need to be factored. All right, now when you're solving equations by factoring, one of the things that has to happen is that the equation must equal 0. Now, what kinds of equations are you going to solve by factoring? These are equations that are the second degree or higher. Okay, if it was just 3x plus 7 equals 0, you'd go ahead and solve it. All right, the second thing that we're going to be doing is factoring after we make sure the equation equals 0. And then we're going to use the 0 property. That means we're going to set each quantity equal to 0 and we're going to solve it. Now, one of the things that comes up is I just say factor. When you look at the problems, they're not going to tell you factor this one using common factoring, factor this one using trinomial factoring, factor this one by grouping, or factor this one because it's a special case. You're going to have to look at the problem and determine what kind of factoring to use. So if we take a look at the first example, I have x squared minus 8x plus 7. Now, what kind of factoring do I need to try there? All right. If you look at it, common factoring, and I wrote a little 2- question mark there. That can have 2 to an unlimited number of terms. So it's possible that you might have to do some common factoring there. As a matter of fact, check common factoring first always. Well, when we look at it, there's nothing in common that comes out of x squared, negative 8x, and 7. Trinomial, it's got three terms. This has 3 terms. So let's go ahead and try trinomial on it. All right, so I'm going to do parentheses here, an x and an x. Are there any terms that multiply to be 7 and add to be negative 8? And it turns out there are. Negative 1 times negative 7 is positive 7, and negative 1 plus negative 7 is negative 8. So I can put my minus 1 and my minus 7 in there. Don't forget to bring down your equal 0. Now that I've factored it, I can use the 0 property on it because I have 2 quantities that are multiplied together that equal 0. So I'm going to say x minus 1 equals 0, or x minus 7 equals 0. These are very straightforward equations to solve. Plus 1, x equals 1, plus 7, x equals 7. Now, students will look at this and they'll say, but wait a minute. That's got 2, yes, it's got 2 answers. It's a second degree equation. It can have up to 2 answers. But they'll say, that doesn't look right. How do I know those are correct? Substitute them back in to check them. Let's just go on ahead and do this verbally. Let's do the 7 first. 7 squared minus 8 times 7 plus 7. Well, 7 squared is 49. And then negative 8 times 7 is negative 56. So 49 and negative 56 is negative 7. And negative 7 plus 7 is 0. It works. Same thing happens with the 1. 1 squared is 1. Minus 8 times 1. Well, 8 times 1 is 8. So it'd be 1 minus the 8 would be negative 7. Plus 7 is 0. So you can always check your answers and put them back in if it doesn't look right to you. All right, let's do the second one. I'm kind of working across here today. I've got x squared minus 9x equals 0. So I kind of run down my list here, common, 2 or more. Hey, do these things have anything in common? And the answer is yes, they do. They both have an x in common. So since they both have an x in common, divide by x, x squared divided by x is x. Negative 9x divided by x, the x's cancel. That is just 9. So now I have x times x minus 9 equals 0. So x equals 0. Not even an equation to solve there, is there? Or x minus 9 equals 0. Add 9 to both sides, x equals 9. So, and again, if you want to check it, 0 squared is 0. Minus 9 times 0 is 0. Well, 0 and 0 are 0. 0 equals 0. And if you check it with the 9, 9 squared is 81. Minus 9 times 9 is 81. 81 minus 81 is 0. So I'm not going to bother checking any more of these, but I just wanted to point out that if you're not sure, you can always resubstitute it in just to check your answer. All right, so now I've got x squared equals 2x plus 15. Equation must equal 0. So what are we going to do? We have to get everything over. Now, you could go minus x squared to both sides. I don't like dealing with negative x squared. I would rather just minus 2x and minus 15, minus 2x and minus 15 to both sides. That gives me x squared minus 2x minus 15 equals 0. Now some of you do realize that if you move something over to the other side, it just changes its sign. I just went on ahead and showed the steps there. You can just, many of you will just move it over, and I get that. All right, now I've got this. Check for common factoring. No common factoring. Let's try trinomial on it because there's 3 parts there. X and x. Are there any factors of negative 15 that add up to negative 2? Well, let's see. 5 times negative 3, that's negative 15, but that adds up to positive 2, doesn't it? So let's use negative 5 times 3. Negative 5 times 3 multiplies to negative 15, and when you add it, it adds up to negative 2. Minus 5 plus 3. I'm going to bring down my equals 0. At this point, you've hopefully done enough of these where you just set the quantities equal to 0. And of course, as I'm talking, I didn't set it equal to 0. X plus 3 equals 0 and solve. Plus 5, x equals 5. Minus 3, x equals negative 3. Okay, again, I factor and I solve. Make sure it equals 0. All right, x squared minus 25 equals 0. Look at it, common. No, x squared and negative 25 don't have anything in common. It's not a trinomial, it doesn't have 3. It's not a grouping, it doesn't have 4. Special cases, 2 or 3. Well, is this a special case? And I know some of you were like just maybe screaming at the monitor. It's a special case, it's an easy one. And some of you were saying, huh? What do you mean special case? Remember, if you've got a minus sign and you can take the square root of both of them, it's a special case. We can go x and x because the square root of x squared is x. And the square root of 25 is 5. And we put in a plus and a minus. And then we use our 0 property and solve. And then plus 5, x equals 5. All right, well that's 4 examples on how to solve equations. All of these happen to be second degree, but how to solve equations by factoring. So I'm going to do a second part to this, so take a look at part 2. It's going to have 3 or 4 more examples, and we can take it from there.